Yes. I think we're okay. Nice. Okay, Hareen, can you read the question? What is it?
One electron orbits one proton at a distance of 10 to the power of 97 meters from
Hang on, slow down. Thank you. I just want to draw what we have. One electron orbits one proton at a distance of minus 10 to the 10 meters. Okie dokie. So what is first?
The electric field strength at the electron's location caused by the proton.
Right, so there's a field coming out from the proton. So we want the electric field strength. So that would be K, Q, over R squared. Or the other formula, if you want, is 1 over 4 pi epsilon 0 Q over R squared. Okay, let's see what we get. And then epsilon 0 is constant 32. And the charge of an electron is constant 23. And the distance is 10 to the minus 10. So I got 1.45 times 10 to the 11 newtons per coulomb. Did you get that also? I think you did this one in class. Yeah? Okay. What's next, Tareen?
Force experienced by the electron from the proton's field.
Okay. So that would be F equals Q. Sorry, I haven't decided if I like big Q or small q. So if I change them, please ignore me. QE (2.31 times 10 to the minus 8 newtons). Okay, what's next?
Acceleration experienced by the electron from the proton's field.
The acceleration of the electron, is it?
Yeah.
So that would be the force divided by the mass of an electron. Whoa, it's big. So far, okay? What's next then?
Periodic time of the orbit of the electron.
Yes. So you can say also that F equals m omega squared, or, so that means that omega will be F over m or with a square root. So I have my force. But also, what's F over m? F over m is A, so you could also write it like this if you want. A over or. I have my A. I'll divide by my or. And I'll square root the answer. So I have omega is 1.59 times 10 to the 16 radians a second. And the time is 2 pi over omega. It's tiny time, yeah? Are you getting the same numbers or not?
No.
No. What went wrong?
0.
0 went wrong? What went wrong?
Everything's wrong.
Maybe it's my mistake.
No. Fine.
You know? For sure? Harian, did you do these?
No, I didn't do D. I did the.
And were the numbers right so far?
Yeah.
Okay. What's next? part 5 or part D or whatever.
Electric field strength at the electron's location caused by the electron.
I think you said that backwards. The electric field strength at the proton's location caused by the electron.
That.
Yeah, that one. So for V, now you have the proton, but the electron also makes an electric field.
But electric field is always in the proton, right?
Both make an electric field. In red, here's the proton's electric field. And then in blue, here is the electron's electric field.
Is it not the same as the one we got earlier?
The electric field strength will be the same here. E equals 1 over 4 pi epsilon 0 Q over R squared, but because the Q and the R are the same, you're right, the electric field strength will be the same. What was my answer earlier, Hareen?
1.44 times 10 to the power 11.
And is the next part the force?
Yeah, so the same.
That's also the same because the Q and the E are the same. What's that?
2.31 times 10 to the power -8.
And is the next part the acceleration?
Yeah. That's different.
Now this is where it's different because the mass of the proton is different. Times 10 to the 19 meters per second squared. Right, what's next? Where's that is?
That's it.
Okay, now. What's the acceleration of the electron that we had earlier? What was it? It was 2.53 times 10 to the 22. And then the acceleration of the proton, 1.38 times 10 to the 19. This is an extra note. Can I continue? So, think about this on the side. Whoops. The proton makes an electric field. Here's the electron, and the electron gets pulled in. Correct? So it goes around. But also, the electron yes? I made a mistake?
Last question.
Yeah.
The answer, the first one, I get it multiplied 10 minus 19, no 11.
For which one?
The first one. It's 19.
Not 11?
I got 11.
I got very big one.
Oh. If this is wrong, then everything is wrong. So I really hope it is 11. Let me double check.
No, but just the number is right, but the last part is different.
The last part? Which part?
No, just mean the 10 power.
This part?
11, yeah.
Yeah. So the number is wrong.
What?
Now hang on, I'm double checking. Phew. No, it is 10 to the 11, Amanda. Yeah. What did you get?
Minus 19.
Minus 19.
Hmm.
Don't know. I got 11. Irene, did you get 11?
Mm-hmm.
I'll check in a minute. Anyway. The electron also makes an electric field. So the proton is pulled to the electron. So my question is, why does the electron go around the proton? Why doesn't the proton go around the electron?
Because the proton is heavier.
Yeah, because the proton is heavier. And you can see that here. The acceleration of the electron compared to the proton is 1,000 times bigger. So it actually means that the proton and the electron, they're both moving. The electron is moving in a circle, and what's happening is the proton is moving back and forth. Well, now I suppose maybe it's more like it's moving around in a small circle, I guess. Yeah. So we imagine that the proton is not moving and the electron is moving, but really what's happening is the proton is moving as the electron's moving around, because the electron is pulling the proton as well.
Sooner or later they get closer to each other, right?
What's that?
Sooner or later will they get closer to each other?
No, actually it's stable. Yeah, I get what you're saying. Will this move in and this move in? And no, it's stable. For reasons that are too complicated to explain right now. Anyways, I just wanted to say that number 2. What's the story in number 2? Harry?
Two horizontal plates are held at a distance of 10 centimeters apart and under a voltage of 1 kilovolt. What charge would 1 gram mass require in order to not accelerate seamlessly?
Okay, so there's a weight down here and there's an up force here from the field. Do I give you the charge? I must give you the charge of this 1 gram.
Yeah, I don't.
No?
No.
Uh-oh. Are you sure I didn't?
No. We should take the charge.
Oh wait, I want the charge.
Yeah.
Thank goodness. Okay, so let's say it doesn't matter if it's positive or negative. Let's just say it's positive. So the electric field is going up. So we want F equals W, QE equals mg.
The positive is above the negative.
Oh, I actually tell you this is positive and this is negative. So then I have it drawn the wrong way. It's going like this, which means it's a negative charge here. Okay. So anyways, we have Q must equal mg over E. So that means Q must equal mg, and what's the formula for E?
V over D.
V over D. So that equals mgd over V, which is 0.001, 9.81, 0.10 over 1,000. So that is 9.81 times 10 to the minus 7. Or if you want, that's 981 nanocoulombs. And the minus, but I don't really care about that. It's okay? It's okay? Or, yeah? One more question, or is number 3 about the 2 plates?
Number 3 is the hard one.
Yeah. Can I go down? Yeah.
Number 9.1.
981,
No.
9.81.
The,
This?
this one, yeah.
0.001.
And 9.81 and something.
NGD, the distance.
This-
Here, this one.
What is the number? 0.1?
0.1, yeah. Yeah? Okay. Let me do the next one now. The question says the top plate is positive, I think. I think it said it. Didn't it, Harry? You said the top plate was positive.
No.
No?
I didn't.
Then Doreen's a liar.
Does that say positive above negative?
Positive above negative. Positive above negative, yeah. I guess you're not a liar, Harry. Good. Okay. Number 3 now. So in number 3, what have I got? 2 vertical plates.
Yes,
Harry,
Yes.
give me the info.
2 vertical plates are held at a distance of 30 centimeters apart and at a constant potential difference.
And you don't know the potential difference?
No.
Okie dokie. We'll call it V.
The plates are 10 meters long. Picture a tall skinny chimney stacked like at a factory. Some dusty smoke of mass 10 to the power of negative 5 kg rises at a constant.
Sorry, 10 to the negative 5 kg.
Yes. Rises at a constant 0.5 meters per second between the plates at a constant speed.
What's the voltage? Basically.
Not all the solid are the entire wire. The particles have a charge of 10 for negative 10 coulombs per dust particle. And then what is the potential difference?
Yeah. So I'll explain this problem here. It's an interesting problem. It was a past exam question, although I think they broke it down into different parts. But I liked it. You'll see in a factory, it has a very tall chimney. I'll try and draw it. So you have your factory. There's my factory. It has a very tall chimney stack. And you see the smoke coming out here. Yeah? Now, this smoke actually has a charge. Or, well, it did in here have a charge. So the idea is, if you have an electric field, the dirt in the smoke, if it has a charge, it will move in the electric field because there will be a force, and it will move to the right and stick to the wall. So that when the smoke comes out, there will be less dirt, sticky dirt. So it's cleaner. All the dirt sticks to the side of the chimney. Then at the end of the day, I'm not joking, there's a little hammer and it hits the chimney, dunk, dunk, and all the dirt stuck falls down, and then it's captured at the bottom. So this then is captured instead of being in the air, that it's caught. And it's black, it's sticky, and it has I think it has a positive charge. Yeah. So it cleans the smoke a little bit. Yeah. So the idea here, here's the dirt coming up, and here's its charge per dust particle, and this is its speed, and this is its mass. And we'll make this the negative plate, and we'll make this the positive plate. Need to fix it? Yeah. It's okay? Yeah. Do you understand the idea here? What's happening?
No.
No?
No. Just like a sticky.
Something sticky and falling down. And
Yeah, okay. I don't know. So here, this is smoke. The smoke has a positive charge. So as it moves up, because it's positive, it will move to the right. The positive dirt sticks here. So when the smoke leaves, it's cleaner, because the positive dirt stuck to the wall. Do you understand now? Yes or yes? Now the question is, what voltage do you need? If the voltage is too small, then the force is not strong enough and the dirt will leave before it sticks to the wall. So, if the dirt was here, it will very quickly stick to the wall. Yes? So we only care about making sure the dirt here sticks, because this is the furthest away. It has to go all the way across. The smoke is coming out like this, you know. So we don't care about the smoke here, because it will quickly stick to the wall. We only care about the smoke here. It has to go all the way across. We want this to hit this before it leaves. Yes? So in other words, we want the smoke here to get here before it leaves. If the voltage is too big, then what's the problem? We just waste energy. Yeah. And it's more unsafe, you know. So we want the voltage that just about works. So what do you think I need to do first?
The E.
Even before the E. First thing I want to know is how much time I have to catch the smoke. So it has 10 meters to go vertically, and its speed is 0.5 meters per second. So distance, speed, time. How much time do I have?
Distance of
Yeah.
0.1.
10 over 0.5, which is...
Isn't it 0.1 plus 10 cm?
Oh, sorry, that's 10 meters, not cm. 10 centimeters would be a very small chimney. 20 seconds. I have 20 seconds to catch the smoke. Yes? We're looking down. I said I have 20 seconds to catch the smoke, because the distance is 10, the speed is 0.5, so the time is 10 divided by 0.5, 20 seconds. So this is looking at the vertical. Now let's look at the horizontal. So if I look at the horizontal, this direction, I have U, V, A, T, S. The U is 0, the V I don't know, the A I don't know, the T I want to be 20, and the S I want to be 0.3. Going to the right, the horizontal. So as the smoke is going up, we look at the movement to the right. Yeah. Right, I really care about getting the A, so I shall use S equals ut plus a half at squared. The u is 0, so the A, let me see, the A will be 2s over t squared, right? 0.60 divided by 400. So the acceleration is 1.5 times 10 to the minus 3. But Newton said the force is ma. So if I multiply by the m, which is 10 to the minus 5, I get the force is 1.5 times 10 to the minus 8 newtons. Yep. Yeah, 10 to the minus 5. Now, what is making it have this force? What's causing this force? The electric field. So what's the formula for the force in an electric field? It's QE, or EQ. Now, do we know the Q? We do. So the E, what's the Q? 10 to the minus 10, isn't it? So the E is 150 newtons per coulomb. But what's the formula for E? V over D. So V over D is 150. So V, yep, over E equals F over Q, yeah. So E is V over D. So V is 150 D. What's the D? 0.3, isn't it? So that is... Yeah, the formulas I used here. Here I used F equals Q over E. Here I used F equals MA. And here I used E equals V over D. E equals F over Q. Messy. So F equals QE, yeah, which is what I used here. F equals QE. And then I bring the E under. Sorry. Don't speak English today. Bring the Q under, yes, to get the E. Yes. Q is 10 to the minus 10. Yeah. A little. A little.
E equals V over D.
Oh, better. E equals V over D, correct. So V over D is 150. Because previously we got the E.
V over D is 150.
V over D is 150, so V is 150D.
Wait, but didn't you say V over D is 150?
Yeah, V over D is 150. So V is 150D. Yeah. And D is 30 centimeters. 0.3. Okay?
Yes.
This is an exam question, or this was an exam question.
This one.
This one was, yeah.
But it's difficult to sing the dirty goes right
Yeah.
in the room.
Well, in the exam question, they might break this into two parts, and also they'll have a picture, you know. But I mean, it's good to practice exam questions, especially difficult ones, to prepare you. 1 and 2 are also like exam questions as well. But maybe the difference is 1 and 2 will be like section A, and number 3 is like section B. Yeah?
What was the definition of electric field?
Nobody likes electric fields. I don't know why.
Yeah, that's why I asked. What was the definition?
Well,